And that's Pythagorean Theorem. And in fact, earlier this year we talked about it, right? A lot of people say that just Pythagoras came up with it, but it was a group of people called the Pythagoreans that actually realized that this would be true. And it is that a squared plus b squared equals c squared. It works only for right triangles. You might want to make a note of that somewhere so that you don't try and use it anywhere. And I'll kind of try and show you why it only works for right triangles here in a second. In a right triangle, we have one of the sides is called the hypotenuse. Okay? Which of the sides up here, I have side A, B, and C. Which of the sides up here, and you can just shout it out. Which one? C is the hypotenuse. Very good. And if it's the longest side, when I square that, it should be bigger than when I square the other sides, right? So that's why I add the other two. Does anybody know the name of these other two sides of a right triangle? Anybody think they know? That might be a hands up kind of thing. Yeah. Legs is correct. Okay. So really what you do is you take the legs, square them each, add them together, and it will equal the hypotenuse squared. Now once again, we talked about why it is weird that that exponent of a 2, we say the word squared. Right? Because literally what it does is it forms squares. Right? Now there are hundreds of proofs for Pythagorean theorem. Okay? Probably one of the more simple ones, and you can put this down if you want in your notes or not, but if I actually turn this side into a square, wow, that's terrible. Okay, make a better square than that if you're going to do it, all right? So it's A by A, right? And you found the area of that, okay? And then you took this one. That's why it has to be a right angle, because you see if it's not a right angle, how do I make these into squares, right? See, that's why that's important, okay? And so this would be B by B. If I take the area of this one and add it to the area of this one, it will equal, ooh, we're going to run out of room, the area of that one. Now do you see that they are actually squares? Literally. Okay? And I'll try and show you that on the very first one that we actually do a calculation on. Okay? So let's try one. We've got X, and we've got a 6 inches and an 8 inches. So is it a leg that I don't know or the hypotenuse that I do not know? Just shout it out. Hypotenuse, you're right. And so now you don't have to be strict with the A, B, C, but a lot of people like that. But what you want to know is it's add the 2 legs squared and it equals the hypotenuse squared. So if we were to follow it, I'll write it up here. You don't necessarily have to. It's up to you. But I'm going to try and follow it. Now does it matter? My legs here are 6 inches and 8 inches then, right? Does it matter which one's A and which one's B? No, because it's addition, right? So there's that commutative property again. So once again, you're going to notice something a little bit different with me. When I substitute things into the formulas, I do put their labels as well. Am I going to require you to do that? No. But it might be a good idea to see where things are coming from. Okay. And that will equal, in my problem, the C is being represented by the X that's over here, right? So we over here, we'll put X squared. The reason I like to put the labels in there, I'm very big as to why the labels end up what they are. Okay? So right here, 6 inches squared. So we take the 6 and we square it. 6 times 6 is 36. And then inches squared means inches times inches, so that's inches squared plus. Okay, 8 squared is 64. Inches times inches is inches squared equals X squared. There's not much I can do over there yet. Whenever you're doing the algebra, it's nice to do any adding and subtracting you can do first, get stuff where you want it. Can I take 36 inches squared and add 64 inches squared? Can you do that? You actually can, right? You can put those together, and that comes up to a very nice number, 100. And then what's the label? Is that inches to the 4th? Yeah, it's just inches squared, right? Okay. Any questions where any of the numbers have come from so far? No? Okay. So now it's X squared. Do I want to know what X squared is? No, I don't want to know the area of that square that would be up there. I want to know just one of its sides. So to find the side of that, you would just take the square root. And if I take the square root of that side, basically they cancel. And I kind of do that. It kind of cancels them out. And so I get an X. But if I take the square root of that side, I have to also take the square root of this side. So I'm going to take the square root of 100, and I'm going to take the square root of inches squared. Okay. So the square root, so in other words, what can I multiply by itself to get 100? 10. And what can I multiply by itself to get inches squared? Inches. Okay? So is that logical that this would be 10 inches? It is. Okay? This is what's called, because they are all integers, 6, 8, 10, like this, and you don't have to write like this, but 6, 8, 10 is what's called a Pythagorean triple. Because if your legs, one of your legs is 6, the other leg is 8, the hypotenuse has no choice but to be 10. It's Pythagorean, it'll work every time. Or if your hypotenuse is 10 and one of your legs is 6, the other leg has to be 8. It's going to work every time. And there is a poster in the room of Pythagorean Theorem. It does move from time to time, but right now, you know, if you're listening to the recording, you might just have to come find it. Right now it's over there. 6, 8, 10 is actually not on that list, though. Did they miss it? Well, how come it's not on there? Yeah. Yeah, it's 3, 4, 5. Okay. This one is actually 3, 4, 5, all of them doubled. You see that? So do you think it works if I triple them all? Would that also work? Yeah. And that one's not going to show up on there either, on that poster. They're going to just put the smallest ones. Okay. So in other words, if I triple them all, what's another one? We could do, what, 9, 12, 15. That's also a Pythagorean triple. Those are kind of the bases. On the poster are kind of the bases that you can multiply up. 3, 4, 5, and 6, 8, 10, very, very popular. But please make sure that the correct number is in the hypotenuse spot on your picture. All right? Any questions so far? All right. Can we use Pythagorean theorem on this one? How do you know? Everybody's shaking their head yes. How do you know? Because it's a triangle. All right. So we can do that because really it's because you can form those squares. So we've got, well, this time we have a hypotenuse. So we're missing one of the legs. Okay, well, let's try it again. So the 5 meters can be either A or B. You told me that earlier. So let's make it A. 5 meters squared plus, well, B is represented by the Y in my picture. So Y squared equals 13 meters squared. Everybody ready? So 5 squared, that's 25. Meters squared is, well, meter squared. Plus Y squared. Anybody know 13 squared? Yep, 169, yep. And then meter squared is, well, meter squared. Well, this is drastically different from the first one. The first one, the hypotenuse, was what we didn't know, so the variable was by itself already. Well, here, this one's not. So let's try and get it by itself. Well, we're going to try and do any adding and subtracting that we can first. Okay? Subtract 25 meters squared. Okay? So on the left side, we have 25 meters squared plus Y squared minus 25 meters squared. So those cancel, and I'm left with Y squared. And on the right side, I have 169 meters squared minus 25 meters squared. Am I allowed to actually subtract those and combine them? I am. And once again, it actually comes out to a fairly convenient number. It might not look like it at first, but it comes out to relatively convenient to 144 meters squared. So is Y 144 meters squared long? That's even hard to say that, isn't it? It's even hard to get that to come out of your mouth because it doesn't even make sense, right? So I don't want to know what Y squared is. So that would be the area of this square if I actually made it. That would be 144 square meters in size. So if it's a square, we have to find one of its sides. And so we take the square root, and those kind of cancel. So Y equals, anybody know the square root of 140? Shout it out. 12, very good. Now again, really you're taking the square root of meters squared. So what do I got to multiply by itself to get meters squared? Well, meters. Okay. Does 12 make sense for right here? Yeah. Now it makes sense not because they made that look longer, but because it is smaller than the hypotenuse. Right? That's why that one makes sense. So with that in mind, these are all integers, right? 5, 12, and 13. Should that be on the poster? Yeah, it's actually the second one on there, I believe. Yep, right up here, 5, 12, 13. Okay. So same thing, any multiples of this one will also work. So this is another very popular Pythagorean triple. Okay. Any questions so far? Okay. So for those listening to the recording, I am going to pause it at the moment because you need to try the next one on your own, which is number 3. All right, we're back. So if you are listening to the recording, don't be a cheater. Actually pause it and try that problem. All right. As I went around, I saw a lot of people that got it correct. Okay. Some of you had to round your answer, though. Right? So we'll discuss what you should do if that happens. So this one right here, we are missing the hypotenuse. So if we're going to do this, c squared is kind of what we're missing. So 1 centimeter squared, because you told me the legs can be either one, plus 1 centimeter squared equals, and in our problem, z, and I'll always do that with z's so it doesn't look like a 2, with that little line through it. All right. So here, a lot of people get strange responses to this one. 1 squared is 1. What's the most common wrong answer? People want to say 2. Yeah, that's not what it is. So 1 centimeter squared. Got it. Plus 1 centimeter squared is equal to z squared. Well, 1 plus 1, we can do that. 2 centimeters squared equals z squared. Well, again, I don't want to know the area of this whole thing, because that would be 2 centimeters squared, right? I don't want to know that area. So we take the square root. So z equals, well, square root of 2, does that come out to a whole number? No. In fact, that doesn't even come out to a rational number. Okay? It's about 1.414. So I'm fine if you leave it as the square root of 2. That's fine. And then it'd be centimeters, right? So if they ask you for the exact answer, you should leave it as the square root of 2 centimeters. If they ask you to round it to the tenths, okay, then you would go ahead, you would type the square root of 2 into your calculator, which would tell you 1.414 and then a bunch of stuff after that. And so you would round it, and then if you did that, if it told you to do that, you should put these little things on there that mean approximately equal to, these little squiggles, right? And then put 1.4, for example, if they said to round to the tenths. Okay? So you have to read the directions. If the directions don't state it, I'll probably take the answer either way. Okay? So just have to decide what was wanted in the notes. Okay, any questions so far? All right. I'm going to give you a formula here that looks very, very scary. It calculates the distance between 2 points, but now the 2 points we're talking about are not going to be like they were yesterday on a number line. They're going to be on a diagonal today. Okay? And sometimes students will struggle with this. But believe it or not, that formula you're looking at right there is Pythagorean Theorem in disguise. That's all it is. A squared plus b squared, and if I squared both sides, it would be equal c squared. That's all it is. Okay? And all of this is in here. Did we ever, in the last few days, take the first coordinate minus the second coordinate? Did we do that? Yeah, we did. And then we took the absolute value. That was just to get rid of the negative. Well, another way to get rid of a negative is square and then take the square root. That's going to work. Okay? And so really, that's all it is. So let's just use the formula on this one, just so you can see the formula in action. So what I do is that once they give me some points, I call one x sub 1, y sub 1. This is just subscript. It's just for notation. Okay? And then if that's the first x and y, this is the second x and y. For those of you that are curious, you can label them the other way. Just don't put x1 and y2 together. That's going to get confusing. Right? x1 and y1 go together, x2 and y2 go together, right, in a point. So now what you can simply do, if you would like, is follow the formula. And in the next example, I am going to show you 2 ways of solving these. So x sub 2. So all you have to do now, it says x sub 2 is what should come first. All right, so according to my labeling, x sub 2 is right here. It's the 6. Minus, in the formula, x sub 1, which is 2. I have to square that. Again, naturally. And one way to get rid of the negative, and also it's basically just Pythagorean theorem is all it is. Plus y2. Well, you got to look at your notation. According to mine, I labeled that one y2, so we're going to go 3. Minus y1, right? I'm just following here. I'm doing y2 minus y1. Okay, so it's 3, which I have to square. Okay. So down here we've got distance equals. So order of operations, that radical is a grouping symbol, which says do everything inside that first. And inside that grouping symbol, we have more grouping symbols, which says do everything inside those first. There's a lot of stuff going on here. So really, if we break it down, we're really trying to do that first and then that. Okay? So 6 minus 2, that's 4, which I have to square. Plus, very nicely, 3 minus 3 is 0, which I have to square. So the distance is equal to the square root. 4 squared, which is 16, plus 0 squared, which is 0. So in other words, I have to take the square root of 16, which is 4. That's for those of you that like formulas and you like to follow them and they work for you. Okay? Does everybody have that down that wants to? Because I am going to erase part of it right now. Everybody got it? Okay. I'm much more of a visual person because I want to know why the formulas work. Okay. You just found the distance from that point to that point. Do you agree it's 4? That's all you just did. Okay. So sometimes it is helpful to look at the points that you have from 2, 3 to 6, 3. The y value is the same. That's just horizontal. Okay. The next one we do is going to be on a diagonal. But I hope you didn't work too far ahead because I am going to actually change the point that is on your notes. Okay. What points do you have there? You have 9, -5, and -6, 12. That's what you've got? Why don't you just kind of scribble those out, make a note that I told you to do that, because you can't just do that in your homework. Be like, I don't like these 2 points, I'm going to scribble them out and change it, all right? We're going to use those two, 9, -5, and -7, 10. Now, leave yourself some room. That's why that's so high up on your notes. Leave yourself some room to do this 2 different ways. I don't know if you want to put like a line down the middle or a line across or however you want to kind of separate it. Or maybe just know that you need more room and write accordingly. Okay? So the first way we will do it is we will revisit the formula way. Because I know there are some of you that are very fond of formulas, and that's the way you like to do things. Okay. So I just like to kind of go, well, that's the first x I saw and the first y I saw, so I like to do it that way. And then the second x and the second y. Because you notice really after that, I didn't use that subscript in the equation at all, right? I'm probably going to do this like left side and right side so that you can see them next to each other. Is how I'll do it. You don't have to follow the same way. So here we go. So according to my notation, x sub 2, which comes first, see that, is -7. Got it. Minus, because it's in the formula, x sub 1, which is 9. But according to the formula, I better square that. Plus y sub 2 is next, which according to my notation is 10, minus y sub 1, which is a -5. Any questions on the substitution there? Again, you could have called this point x1, y1, and that one x2, y2, and it's still going to come out to the same number in the end. It doesn't matter. Right, order of operations. Basically, yeah, it sends you right back into here if you follow the rules, right? So what do we got? -7 minus 9, that's -16, right? Which I have to square, plus, well, it's 10 minus a negative, so add the opposite, right? So 15 squared. Some of you may know some of these, some of you may not, right? The first thing, if I take a -16 or just negative in general and square it, that means a negative times a negative, right? Which makes it a positive. So does anybody know 16 squared? Yeah, 256. Anybody know 15 squared? Yeah, 225. Very good. So now order of operations would say add those things because we're still in grouping symbols. There's just a lot of them here in this formula. And what do we get there? 481. Now here's where 481 is not a perfect square, right? And so you have to look at the directions. Does it say I have to keep it exact? Does it say I have to round? But I don't know if you, I'm looking at the side of a triangle. The square root of 481 is really hard to visualize, right? So you might want to get some decimal to see if that makes sense to you. Somebody have their calculator out and have that figured out? 21.9 approximately, is that what it is? Again, I use a little squiggles, right, for approximately equal to 21.9. So do you have any questions on that method? No? Okay. 9, negative 5, huh? So 9, negative 1, 2, 3, 4, 5. Is 9, negative 5. Way over there. Negative 7, 10. Way up there. What you're trying to find, and I'll probably miss the points when I do it. Well, that's actually not too bad. Normally there's a big bow in my line when I do that. It's pretty good, actually. What you're finding is how far is it from there to there. Now, a lot of people want to say, well, can't I just count like from here to there? That's 1, 2. Yeah, that doesn't work because this distance is 1. That distance is 1. So we have to find out how does that work because we aren't going either vertical or horizontal. But could I get from one of those points to the other one by strictly going vertical and horizontal? Can you do that? Like if these were the streets of a city, you're not going to be going across lawns and stuff like that, right? Like they are now. Well, at least hopefully you're not. You would have to try and get there another way. And so let's just do that. Let's try and get there another way. Oh, no way. That's a right triangle. You got to be kidding me. Look at that. Right triangle right there. So what we can do, can anybody tell me the coordinates of this point down here in the corner? Can we figure that out? I think we had an assignment like on the assignment the other day. Yeah. Negative 7, negative 5. Any questions on where this picture came from? So could I find the length of this side and find the length of that side and do Pythagorean theorem to find the length of that side? Yeah. Do you realize that's what you just did using the distance formula? It's the exact same thing. Okay. So now if you want to, this is straight vertical. So I'm going from 10 to negative 5. Could you use that little absolute value thing we learned the other day? Yeah. Absolute 10. Whoa. There we go. Minus a negative 5. How far is that? 15. From here, I'm going from negative 7 to 9. Could you use that again? Sure. Negative 7 minus 9. So this is? Do we see the numbers 15 and 16 anywhere over there in that other work? That one happens to be negative because maybe they just went the other direction. And technically, you know, if you're going down, you would have called that negative 15 as a displacement. Okay. All the distance formula is Pythagorean theorem. Because am I going to do all that exact same work now? From here on down, I'm going to do the same work over there. I'm going to take 15 squared plus 16 squared. You think it's going to add up to 256 and 225 again? It sure better. So is it going to add up to the square root of 481 again? It better. Okay. So did we get the same answer? Yeah, we did. Because all distance formula is Pythagorean theorem just manipulated for you. Do I care which way you do it? No. Okay. But I have had a lot of students after they've seen this, is they do a lot of it in their head. Be careful with that, right? Okay. But they try and say, well, how far down do I have to go? How far across? There you go. And then you found out how long that has to be. Because let's face it, before this, you probably didn't think these two things should go together. Pythagorean theorem and distance formula. Okay. They are the same thing. Last chance. Yes? Sure. I was asked to scroll up, so here we go. Yes. Okay, very good question. What somebody noticed is that this coordinate is kind of getting used right here, right? Okay. And it is going to match up a lot because where did I get the -7, -5 from? From the original coordinates, right? Okay. Okay. Be careful to generalize it that much because then you're going to get confused what number goes where, right? And then you're going to be making more work for yourself. But that's an excellent observation. Mm-hmm. What I would do is either draw the picture so you can see it or use the formula. Anything else?